Are you looking to learn AWS Solutions Architect interview questions? If so, this video is for you. Hi, my name is Michael Gibbs and I'm the founder and CEO of Go Cloud Architects, and we're an organization dedicated towards building high-performance cloud computing and technology careers. Today I'm going to talk to you about some AWS Solutions Architect interview questions, because in order to help you with your cloud architect interview, we want to make sure you're prepared. So when it comes to getting your first cloud architect job or getting a tech job in general, typically speaking, the hiring manager has to gauge your level of technical competency. And the way they do that is with a cloud architect technical interview. And they gauge your technical competency by the way you respond. But it's not just the technical competency that we're looking for when you give you a technical interview. We're looking to see, do you know the technology, how it works and why you would use it, but also, can you communicate that technology? So when it comes to being an architect, you may spend 50% of your time writing and 25% of your time presenting, and how you can present technology becomes critically important to your technology career, especially as a cloud architect. It's not a career where you're going to spend your life constantly typing. That's what cloud engineers do, and that's fine, but train for the job you're looking for. So if you want to train to be a cloud architect, make sure you train to be a cloud architect. And part of that is mastering the interview so you can get your first cloud architect job. So we're going to ask you 5 questions today, and we're going to start with a very easy one, and we're going to work our way up through the complexity. And as we do this, we're looking for certain things. So as hiring managers, we're always going to ask open-ended questions, because we want to see, how you're going to answer it, but also how you describe the technology. So the first and most basic question that I'm going to ask, and this is a commonly asked question, and you would think it's super easy, but I've asked this question over 500 times and I've yet to get a correct answer unless someone's been working in technology for a long period of time. But for people that are just certified that have never worked in tech, I've yet to get a correct answer, so we're going to cover this, especially because it's covered a lot. What is EC2, or Elastic Compute Cloud? This is a common question. So what is Elastic Compute Cloud? We are not looking to hear an instance. As a hiring manager, the reason we ask what is the Elastic Compute Cloud is we want to know if you actually understand what the technology is. And the Elastic Compute Cloud is really just a virtual machine on the AWS cloud. See, the cloud is a virtualized network and data center and nothing more. So what really enables cloud computing is virtualization. So whether it's like an EC2 instance, which is a virtual machine on the cloud, whether it's a container, whether it's a VLAN or with a .1Q tag while you're trunking your data to AWS, it's all virtualization. So what is EC2? It is a compute instance, which is really just nothing more than a virtual machine. Know that an EC2 instance is a virtual machine, and you'll show the hiring manager that you have an idea of the underlying technology of the cloud. The next question I'm going to ask, when it's a common question, is what is caching and how does it work? So what we're looking for is, do you understand the process of the cache? Do you understand cache hits and cache misses? And we'll talk about what that is. So the way you would answer a question like that, you could say caching is a way to offload servers by storing frequently accessed information in a cache. Here's how the cache works. If a user tries to request information from either a database or a website, for example, that's been cached, the user will first go to the cache. If the cache has the information, it will be sent directly to the user. If the cache does not have any information, you have a cache miss. The cache will go to the source, maybe it's a web server, maybe it's a database. It will then take the information, put it in the cache, and then serve it to you. Now the next person that requests the same information will go to the cache, request that same information, and the cache will say, it's here, and serve it to you. So caching really can improve performance because it can make sure that you don't have to go all the way back to the web server. So if you're traveling over great distances, this can reduce latency and improve performance. It can also extremely beneficially enhance scalability, because if everybody's requesting the same content, it does not have to go back to the web servers because it's all stored on the cache. So caching can be a fantastic way to boost performance. A little bit more to know about caching. If you cache your data for too long, what can ultimately happen is you'll have old data. So typically speaking, you set up a time to live. For example, if you were to change your web page every 24 hours and the cache's time to live was a week, users would not get the new web page until the cache timed out, which could be up to a week. So that would obviously be problematic. So you're going to set the cache timeout to be important answers related to your data and the frequency of data changes. So how does the cache work? You go to the cache. If it has it, it sends it to you. If it doesn't, it goes to the source, brings it back, delivers to the cache, and then sends it back to you. Subsequent requests for that same information will all be served by the cache until it times out based upon the time to live. Now you know about caching, and you know how it works, why it works, and why you would use it. The next question is, what is DNS, and what are the key record types I should know to pass on my Cloud Architect interview? And what is DNS? DNS, or the domain name system, is really a means to map an IP address to a user-friendly name. Could you imagine trying to remember every IP address on the internet? Of course not, it'd be impossible. But it's easy to remember Cisco.com or Amazon.com, and it's not so easy to remember their address. So that's the purpose of the domain name system. Now, the domain name system can also implement how you actually share traffic. For example, you could route traffic to different types of web servers based on latency. You can do it based on the geography that they're in, or you can do it based on weighted values. So there's lots of ways you can manipulate your traffic with DNS, but DNS, the main function is to map a name to an IP address to a name that's user-friendly for humans. Now, there are some really key record types that you need to know as a cloud architect, and you could potentially be asked on a cloud architect interview, and these are the main record types. There's an A record, which is a simple record that maps a name to an IP address, and that's for IPv4. And if you're working with IPv6, there's an AAAA record, and that's just basically an A record, but for IPv6 addresses. Now, you're going to have a CNAME record, which is really where you map one domain to another domain. And that's another common record you'll be dealing with. Now, if you're working in an environment where an organization desires to receive email, they're going to have to set up an MX, or a mail exchange record. Typically, you'll work with a name server record, a start of authority record, and they're your main records. But it's really important to know that DNS basically maps an IP address to a user-friendly name, and we've covered the main record types with you. The next question is, what is SQS, and why would you use it? SQS, or Simple Queuing System, is a queuing system. Now, people that are not familiar with queuing and they're not familiar with middleware type applications can look at this and say, what exactly is this? So let's say you've got data here that needs to be sent to here. And let's say the data can be sent from point A to point B, but point B is too busy to actually receive all the data when it receives it. So what does point B do with extraneous data? It just drops it and it all falls away. And messages are lost. So the way you could get around this problem is twofold. You could make sure that the server on the other end is bigger, and that way it would be less likely to drop traffic because it has more compute resources. So that's one of the ways you can do it. But you can also, instead of making the server bigger, take an intermediate hop. Point A, A.5, B. So you send all the messages to A.5, or the midway point. It stores all these messages in a queue, or a holding, think of it as a holding place. And then it will deliver the messages one by one to the end destination by draining them from the queue. And if this is too busy, the messages will stay on the queue. So it can smooth out the messages that are being sent to the server. So when you're doing this, you're getting a following benefits. First, you're decoupling A to B by adding that intermediary. So you've got a scalability factor that can go. You can now scale independently both sides because you decoupled them. Also, it enables you to save on cost because the queue itself will be drained at a period where the server that's receiving the information can go. And if you're dealing with a highly scalable environment, you already have to go up to the bigger servers or the biggest servers that are available, and it's still not enough, you can use this queue as a message midpoint between the source and the destination. So SQS, or Simple Queuing, enables you to decouple your application architectures and create an intermediate to make sure that you don't lose messages along the way. The next question is, what is auto-scaling? Now, if you're a cloud architect, you should be very excited by auto-scaling. See, without auto-scaling, here's the way things work, and be able to describe this to the hiring manager. In a non-auto-scaling environment, you have to buy the biggest server you can to meet the needs of your busiest day, your busiest minute, or busiest second of the year. Otherwise, you lose things. So how does an organization typically do that? Let's say an organization is a retail store. Let's say they have 1,000 transactions per second normally, but around the Christmas time, they have 1,000,000 transactions per second. What do they build? What are they running? All year, they are running a server that's big, or a group of servers that are big enough for 1,000,000 transactions per second, because that's what they're going to have on their peak. But they're really only at 1,000 all the time. So as you can see, that gets very cost ineffective planning for the peak as opposed to planning for average. So By using auto-scaling, what auto-scaling enables an organization to do is basically buy a compute instance or a virtual machine that supports their needs right now, and then add additional virtual machines if the need grows. So instead of prepaying in advance for the 1 minute or the 1 second per year when you need max capacity, you can basically use a computing platform that meets your average needs and then scale out by adding as many computers as possible to meet your computing needs, or as many as necessary. So when you're setting up auto-scaling, basically you have 3 things to deal with. You have the minimum size, the desired capacity, and the maximum size. And what is that? The desired capacity is what you'd set that basically says, I'd like to keep 2 systems up and running. The minimum capacity is like if nothing's going on, what is the smallest it can run on? And the maximum size is how many could it add? Do you want to add 5? Do you want to add 10? Do you want to add 50? So the maximum size determines how many additional compute instances that can scale out. But auto-scaling is an amazing way to basically optimize your computing costs. Auto-scaling is one of the key drivers for moving to the cloud, because basically you can only purchase for what you need and then scale out as necessary. So now you know the things we talked about today. We talked about an EC2, which is really nothing more than a virtual machine on the platform. We talked about caching and how it works. We talked about what is DNS and the key types of record types. Then we talked about what is SQS and why you would use it. And then we talked about auto-scaling. Let me tell you about some things we do for the Cloud Architect community. Every Monday and every Thursday, we have a free How to Get Your First Cloud Architect Job webinar. On this webinar, we'll teach you things about interview skills, a resume that's going to get you hired, how to basically present yourself in an interview, what hiring managers desire, how to get the kind of experience that hiring managers desire, and so much more. And it's free, and we do it on Monday and Thursday. And we usually even let you ask us questions, and we coach you on your career. And it's all free, and we do this on Monday and Thursday. Every Tuesday, what we actually do is we have a Cloud Architect Experience webinar. People ask us all over the world, how do they get real Cloud Architect experience so they can get hired? And we tell you exactly what to do in this webinar. We do it free every Tuesday. Most Wednesdays, not all, we have a live stream on YouTube where we let you ask us any questions you have about Cloud Architect careers, and we answer them real time. We do that most Wednesdays, not every one. So please subscribe and you'll find out when we have them, or we'll notify you on social media, or if you're on an email list, we'll also notify you. Now, let me tell you that if you're working on an AWS Certified Solution Architect Associate, we have a free course that we give away. The link is in the description below. And we even have a free AWS Certified Solution Architect Associate ebook. And that book can help you with the course. The link again is in the description below. We are writing an AWS Advanced Networking book and an AWS Advanced Security book as an organization, and they'll be ready in approximately 8 weeks. We're going to give them away completely free. And if you're interested, in the description below, we have the link to pre-register for those books. Thank you so much for the opportunity to work with you. It's an honor and a privilege to be able to work with the Cloud Architect community, and we're so excited to be here. Thank you so much, and I look forward to seeing you in another video very soon.